Hello guys! In this lesson we will discuss the edge and skew alignment options for Align tool. As Align tool is one of the main instruments to align surfaces and edge and skew options within one of the main variables, it is beneficial to know all the nuances of their behavior. They may look quite simple, but in reality they have some situational related discrepancies. On top of that, these oddities are undocumented, so it will be difficult if you're outside of the industry, figure it out by yourself. So let me guide you. I will start with edge align options, a couple examples, then skew align in a couple examples, and a conclusion. Right, let me open up the layer. Okay, first of all, what these options for? Both of them, the edge and skew, are designed to constrain infinite amount of surface boundary directions within the desired continuity. In most of the situations, alignment may have plenty of solutions, and edge and skew are designed to define them. Edge align options in particular are designed to constrain edges of the surface to be parametrically aligned to the isopalms of the surface, not necessarily to the edge of the surface. Now, I always said and say it again, Alias devs are really bad at naming, and this edge, I put it in quotes, is quite confusing because this is not what's happening in reality. Let me show you. So I will create a surface just using skin like that. Let me bring more degree. Oops. Let me bring more degrees like that, and I will align it with the default parameters. So I'm aligning with G2 constraint, and in the alignment type, as you can see, automatically it is the edge. So the edge alignment comes by default. I believe you already know this. So let me do that. So what you see here is the let me remove the extra C0. Now, as you can see here is just quite a common thing. So it works as intended, and on the both sides you're going to see the start edge and end edge. These edges are basically marking the edges of the surface, and they are following collinearly to create the desired boundaries of the surface, basically following the edges. So this is something you're probably already familiar with. This is the standard mechanic of the align tool. Now, if I will use partial alignment instead by just moving the handle, you're going to see that something changes. Well, what exactly happening? What will happening is that Alias realigns the surface again and again and again, over and over. And if you look closely, you will see that the actual edge which we have here is now changing. You see, so for example, here it's visible. This is not the same as it was here. So edge align is not aligning to the true edges of the surface, to the untrimmed boundary representation of the surface. Instead, it aligns to the isopalms, which means aligns parametrically. Now, if you don't know what is the difference between parametric alignment and a geometric alignment, I made a video about that. I will put the link in the description. But in short, it aligns to the isopalms, and the isopalms are just a visual representation of the domain of a parameter. Now, if you look closer here, you will see that these lines, they created using the patch precision tool, which I can increase or decrease. Now, these dotted lines are isopalms. And these isopalms, just a visual representation, as I said, of the domain of parameters of the surface. On these intersections, you can think about them as points. So every intersection is a point, and there is a grid of points. You probably know that NURB surfaces are always squared surfaces, and they have the domain of parameters which define their shape. And the isopalms, they just visually show you this domain of values. And as I said, this is a points. Technically, this is not a points. This is a t parameter, just a variable which you can change in the polynomial equation, which basically creates the surface. And you can increase or decrease amount of the isoparms, but technically there is an infinite amount of them. In practice, of course, it's not. We can't work with infinities on our computers. They will crash and burn. But there is enough. There is enough of these points, basically close to infinity. And what align tool does is that it aligns parametrically to the surface, which means it aligns to U or V direction, depends on the edge you're aligning to. And what it does, it just picks the correspondent row or column of these parameters and then aligns collinearly to them. For example, if I will use history, and as you can see, I have a couple curves and surfaces, these and these ones. I basically placed them specifically where the isoparms goes, just to illustrate. And if I will move that, once again, I'm in the partial alignment, so I will move that and snap it to this point, you're going to see that the collinearity still persists, but it works from the isoparm of the surface. And if I'll move it here, for example, you can see that now it just aligns to this one. So Alias with edge align option is not really taking edges, it's taking isoparms. It's taking domain of points from the surface, from U and V directions. So that's what it does. And it's very, very beneficial behavior. This, without the edge align, it will be really difficult to model. Every single time you need to create like curves, basically. So yeah, this is the intended way of working with that. The most important thing, once again, it's not taking this edge and carry it through. No, it always recalculates. And this is, as I said, default behavior. But there is a catch to the edge align in general, and not only the edge align, the skew align as well, and we will talk about that a little bit later. So the problem with edge align, well, apart that it is just called edge, is that if the surface is trimmed, the behavior may change. It may change or it may not. Depends on how you trim the surface. So let me remove patch precision for now, and I will remove these two curves and surfaces, leaving only this one. So this is a single surface, as you can see. And right now, if I will use Query Edit and right mouse button click to see the parameters of the surface, you're going to see that the parameterization of this surface is uniform from 0, 0 to 1, 1. Once again, this is in U and V domain. And it's unchanged. This is great. This is exactly how it's supposed to be. Now, if I will trim the surface like this, and check it again, you're going to see nothing changes. So the reparameterization didn't happen. The parameters is still within 0 to 1 because we didn't change the surface. We just visually trim part of that, creating additional arbitrary edge. So it has some parameters, some T parameter, which we don't know which one it is, but it's there. And when we made that, the behavior of the edge align as well as the skew align may change, but it really depends on how you trim the surface. In this situation, nothing will happen, and the surface will behave the same way as it's supposed to. Sorry, the surface, the align operation will happen, no problem. It still works how it's supposed to be. If I will, if I will cut the surface like this, for example, creating a hole or something like that, once again, it will work just fine. The problems will happen when the adjacent edge will be trimmed, and not just like a little bit, but completely chopped off. And it doesn't really matter which one. The edge align just stopped working properly. Let me illustrate. So just revert that, and I will go to the next example. So here, as you can see, this is the same surface as it was, but I will put two just arbitrary curves and surfaces, and I will trim the surface. Once again, the parameterization is still left intact as it was, but now if I will try to do the edge align, let me bring 2 degrees or 3 degrees for curvature, it works from the general standpoint. It looks the same. The edge aligns works the same. It just corresponds to the new direction just fine. But the moment you move this using the partial alignment, what's going on? Well, now it just stopped working properly. So in the body of the surface, where there is no between the extremes of the domain, it just takes the normalized vector instead of being edge align. In fact, if I will click on the edge and change it to skew, nothing will happen. And the reason for that is because it's not edge alignment anymore. So instead of aligning collinearly to the surface, it aligns, basically parametrically, it aligns using geometric constraint. Once again, I will put the link about the parameterization in the description to this one. So yeah, that's, well, that's strange, isn't it? And this is not how it actually is supposed to work. This is undesired behavior. If I will put that back to the original ones, well, now it works as it's supposed to, right? Well, but this is not the old problems. If I will revert that and imagine that I will just delete these curves and surfaces, and I will try to align to this surface somewhere to the isopalm. Let me just kind of quickly do that. Like this. Let me use the blending. Actually, I delete the history like this. So imagine that the surface was like that, and now I need to align these with edge align. Now, if I'll perform the alignment, you're going to see that it still kind of corresponds with the edges. Now we are having some the row of numbers somewhere in the middle of the surface, and it still works. And by the way, in the documentation to the Alias, it's actually mentioned that edge align should work with the trimmed edges, and to some extent it does, but only if this is a true edges and only if it's not partial, because if it is partial, yeah, that's it, end of story. So the reason why it happening is unknown to me. Now, the Alias developers didn't really actually describe how they reparameterize the surface beneath the hood, but that's definitely tied to the weight, to the algorithm itself, so which is not perfect. And then you get these situations. Once again, you will not spot that if you're aligning to the edges and at least one of the edges of the surface is a true edge, so the real edge of the surface, and you're aligning to that, basically edge to edge, it will work. So it should have at least one adjacent edge will be a true edge. If it is not, and they're just somewhere in the middle, this is a curved surface which you created somewhere here, like here, for example, then yeah, you are out of luck. So it will not behave like the proper edge alignment. It will not be collinear. It will not follow the isoparms. It will not be aligned parametrically. Instead, it will be aligned geometrically using the normalized vector. So what are we going to do with this? How can we overcome these problems? Well, there is two options for the edge align. Let me illustrate. So first, let me actually let me show it here. I will yeah, I already have the surface here, so let me show it like this. So let me just quickly project that. Doesn't matter how. So what you really need to do when you performing the alignment operation, well, as I said, there is two options. The option number one is before you trimming, you perform the align operation first. So instead of aligning like this, you retrim your surface, you align first. Is it probably not continuous? Let me just kind of increase the amount. So it just kind of works like that, for example. So, and then you trim. And if you do that, then as the align option works within the history, and in the previous video, I actually showed you how the accept align works. If you're interested, I put the link in the description to this as well. Now, it already stores, the align operation stores the original boundary representation of the surface, so that you trimmed it afterwards doesn't really impact this. And as you can see, in fact, the edges, as you can see, they're not following each other because it aligned to this surface. And yeah, you kind of sacrifice the edge, but if you're talking about the behavior within the domain of points, it actually behaves as it's supposed to. Now, what if this is not exactly what you want? You want that the align tool with edge align works properly, but you want to have the new edges of the surface. You really want it to just align like this. So following the edge from one side and being properly distributed somewhere along the surface. Well, the only way of solving this is temporarily converting the surface to the new surface. So what I'm going to do is I will just trim convert using the trim convert tool, and then let me just kind of revert this, and then I will align to this new surface. Oh, we have a lot of skewing, but regardless. So, and when we have this, I can now hide this surface and left with my original one. Now, there is a chances that you will lose your continuity, because when you rebuild the surface, it rebuilds it with a specific tolerance, with a specific approximation. Deviation may happen, and this is exactly what happened. But now, when you have the proper directions of the surface, it's really, really close to the curvature. You can delete the surface, or sorry, the history, and realign that already to the new one, and it will maintain. So, two options for you in this situation when we come into the edge align options. Now, that's not really very convenient way of modeling, but everybody who actually within the industry, they know this nuance to the edge align and the skew align options pretty well, because they exist for as long as I remember, as these new align tool was introduced, replenishing the previous one, the align 08, and this is just how it works. So what happens with the skew, and what is the skew? Now let's go to the skew. No, let me just actually delete the surface. All right. Okay, now let's talk about the skew. Well, you probably already guessed that all the problems with the skew are actually related to the trimmed surfaces as well. And that's absolutely true. It's exactly like that. So the edge alignment options have problems when you have trimmed surfaces, and the skewing have relatively the same problems. But the skewing itself has one important property which I need to discuss first, and this is the skewing angle. So if I will create a surface and basically do the same thing, I will align it as a curvature. Let me align that as a curvature, but instead of the edge, we already talked about that, I'll switch it to skew. Well, something happened. Well, as the name suggests, it skews the angle. Well, it looks like so, it really skewed, but why it's skewed like that? Why it's skewed like that? Now, as you can see, there is these green lines. These green lines are the proximity display. It shows you the previous state of the surface, which was stored before the alignment operations happens. And the alignment operations relying on the stored data really heavily. So if you look at this stuff, we will see that it's skewed. And on top of that, if you scroll to the outer edge options in the align tool, you're going to see that there is, let me just kind of rearrange it. Yeah, there is these start skew angle and end skew angle parameter, and it's set to 0. So Alias suggests that, not suggests it, it claims that this specific angle is the skewing angle of 0. Why was that, right? What the hell is going on? Well, it's actually very simple. The skew align aligns the surface the way that it's still tied to the boundary of the surface. This is one of the main properties of the skewing, is that it inherits the boundaries of the surface. So these green lines, this default state. And even though it doesn't look like so, because yeah, it looks like obviously they actually like not the same. It really depends on the point of perspective. Really perspective. So if we look from the tangent plane from the surface you're aligning, this is the tangent plane of the surface we're aligning to, and actually let me activate this. So set construction plane, yes, this is one, and look at it. Oh, look at this. Now the boundary is actually matching 1-to-1. So this is not some random angle. This angle is the same angle as from the original surface, but from the tangent plane of the surface you're aligning to at a point, so at the edge. And in fact, if I will, you're going to see that here they're not matching. Well, that's because we're looking from the wrong direction. If I will activate this plane and look at this one, like that, you're going to see now it's following. And this is the intended behavior of the skew align option. It maintains the boundary from the tangent plane of a surface you're aligning to. And this is a very, very, very useful property of the skew align, and I will show you the next example here. But first, we need to cover the oddities of the skew align. And the oddity, as I said, is the same. It ties to the fact that trimming the surface, messing up with the algorithm of the skew alignment. Now, if I will revert this and imagine that I will trim it somewhere. Now, it doesn't matter in this situation in comparison to the edge align. With the skew align, it doesn't matter where you trim. Any trimming operation will lead to, some extent unpredictable behavior. I'm not saying unpredictable. It's not random. It's foreshadowing. So if I will, oops, let me just go to the top like this, and I will just cut it. Once again, it doesn't matter. I can project a circle here, for example, and make a hole. It really doesn't matter. The moment you do this, let me trim this, and then I will align that to the skew. Well, it looks like, well, it probably looks the same, right? But once again, if I will, I'm now in this view, so if I'll align my view and check, yeah, it's not following anymore. And if I will go here, once again, it's not the same. So the skew alignment doesn't really works properly. The default angle is not really inherited by the original boundary of the surface, which to some extent tied to the different parameterization, that the fact that the surface itself was reparameterized somewhere within the algorithm, but it's not in your face. So if you check it, you're going to see that by default it still shows you the original boundary. So you don't know how it reparameterized that, but it does, and instead it's just taking the resulting vector of it. This is not beneficial. The reason why it's not beneficial is because it's uncontrollable. So you have your angle, you can move it, yes, but these 0, 0 parameters are not really tied to anything. On top of that, it doesn't matter how you trim. You trim it like this, you make a hole, you make it an arc, the result will be literally the same, 1-to-1. So it doesn't really take the, it reparameterize it in a different way, and the actual trim is not really in effect. The moment you trim it, it's all gone. So now the skewing angle is not matching the original angle of the surface. Now, what are you going to do with this? How to solve this situation? Well, pretty much the same as with the edge align. What you really need to do is you need to align first and then perform the trimming operation. So let me quickly show you. So I'll go revert. Let me retrim the surface, align it first. Once again, I can look at the edge just to be sure that, yes, now it's following, and this one is following, and then I will trim. And as you can see, yeah, now it works. Now, on top of that, another important thing which I want to mention, let me retrim, let me revert. If I will align partially, so I'll go to the partial alignment and move, the parameterization between the beginning and the end of the domain works in skewing obviously geometrically. So it's not trying to align parametrically to the isoparams. It doesn't really take the isoparams into the consideration at all. And what it does, it just aligns geometrically between the two vectors, which is in the intended way. It's supposed to work like this. Yes, just exactly how it's supposed to work. Now, once again, it isn't really matching because I'm not looking from the proper direction. I'm on this plane, so it's still following. Here it is. But if the surface is trimmed, and I would like to mention again, it doesn't matter how you trim it, because with edge alignment, you can get the proper edges if you're not in partial alignment, and your edges will not be, your alignment will not be deformed if you still within the full length alignment. So all the points of the domain are of the edge and adjacent edge exist. I'm just let me say it in other ways. I'm sorry. So what I want to say is that with edge alignment, the way how you trim surface matters. In some situations, as I showed you in the previous example, the edges still may be maintained. The problems will happen when you use partial alignment. But with the skewing alignment, as I said before, it doesn't matter. The moment you trim it, you change the behavior of the skew alignment, and it's not technically working the proper way. Now, and if I will trim the surface here, and I will now use partial alignment, it still works because the alignment happens before, and I guess you already get that. But if I will revert, and I will trim, and then I will align, and I will try to move, you're going to see that a part of the fact that the boundaries are not matching anymore, the actual angle and the skewing angle is not following the direction of the surface anymore. So it's not changing. It's kind of stuck in that arbitrary position and this kind of random direct, not random direction. Once again, it's the resulting vector, but it's keep it, and it's not changing anymore. Now this is there is not a lot of uses to this. You can probably find a good usage to this, at least in a very situational, probably. But this is a hack. This is not something. It's not the proper way of doing and using the skew. And once again, the reason for that is because the surface was trimmed. And to solve this, you need to go back, as I already showed, retrim, align, move that, and then trim. Right? So now it works as intended. Okay, now let's go to the second example, and actually I believe it's pretty clear why edge align is useful, because it creates the proper natural transition between the edges of the surfaces and create the flow. But the skew doesn't create the flow, or at least it doesn't create a natural flow. Instead, the skewing angle gives you an ability to create your custom flow, or it's very the really prominent usage of the skew alignment when you rebuilding some parts of the fillet, for example. So you have a piece you removed, and you want to have these surfaces which forming the fillet. They're not collinear with the surface they align to, which is happening all the time. And then you use skew because you take just the current boundaries, and you don't want to try to adjust the surface. You want to just kind of project. So. And this example, I believe, will illustrate it quite good, because you're going to see that I have the specific desired direction of my surfaces, and there is two of them. So I made it manually, so I will take one row, moved it in one direction, I'll take another row, moved it in the opposite direction. I basically sculpted my boundaries the way I wanted them to be for my model. And now when I will perform alignment, I would like to keep it. I would like to maintain the same character. And that's where the skewing alignment will be helpful. So on top of that, as you can see, I have, just to illustrate it again, which is quite important, I have the same surface, but one of them, they looks the same, but one of them is has the natural boundaries. It's not trimmed. It's trim converted, and the other one is not. It is trimmed. So actually, let me show you. So this is the surface, and as you can see, it's trimmed. And if you will not pay attention, if you will try to align it, maintaining this direction, once again, to maintain this, remember which we saw here with the inherited boundary, the skew will inherit the boundary, and I assume that now I can align these two pieces and they will match positionally. But if I actually try to do that, let me actually hide this one and align. So I'll go to G2 with edge. And with the skew, well, it kind of did something, but obviously it's, as this is a straight line, I can see from the top, I'm gonna see that it's not following the proper direction. And if I align this one with the skew, yeah, not even close. So if I will check it, you can see there's a huge gap because this skewing works properly and these one do not. And we're gonna say good luck aligning it now. No, of course you can, you know, but that's not exactly what you're looking for. So instead, I will revert this one, and there is obviously the easier way of doing it is just temporarily convert the surface. So I can convert that, make a part, and then realign. And yeah, now they are positional. You see? Perfect. This is exactly what I want. Now, what else? Let me just kind of quickly finish this now because there is still no curvature. Now, if you watched my video about the cross-align method, then you know that the proper way of doing that is just create a slab and then use the alignment, align these two through the third surface. And if you're interested, I will put the link in the description to this method as well. But as this is not the topic of alignment operations, let me just quickly align one to another and call it a day. Like this. Now I have some curvature deviation, and the reason for that is probably not enough space. I will click on tangent balance. And here we go. Now the reason why tangent balance works here is what the tangent balance does, is that it basically mimics the same tangent and curvature scale, the distances between the position and tangent row, tangent and curvature row, and basically flip it on the surface you're aligning. So basically mimicking the structure. And this is a great way to create curvature. In reality, it's rarely useful, that much useful, because you want to have a really specific form, but in this specific situation, it works. Okay, so as a conclusion, let me sum this up quickly. What you should do with the edge align and what you should do with the skew align. So with the edge align, if you aligning to the true edges of the surface, you will not encounter any problems. It will work as it intended to do. If the surface is trimmed, it depends on how it's trimmed. If you cut the adjacent edge to the edge you're aligning, your partial alignments will be distorted, will be deformed. The edges will still follow. If you trim convert the surface, which you trimmed temporarily, then you will have no problems. Alternatively, you can maintain the same parameterization of the surface before you perform the trimming operation. Let me just quickly show you that again. So you aligned not to the original surface. Oh, sorry, let me just kind of trim that like this. So you align to these kind of yellow boundary, right? And even though that you sacrifice your edges because they're not following anymore, the body will work as intended. When it comes to the skewing, the good rule of thumb is align the surface as a skew before you perform the trimming operation. Otherwise, it doesn't matter how you trim it. If you trimmed it, your skew alignment is no more, is gone. You will not have the proper result. And the only thing you can do is to, as I said, to untrim and align first, or trim convert your surface. And one important note at the end is that there is a lot of design bureaus who actually use this nuance of align tool, and specifically the edge and skew options, to test applicants. So the guy come in, he want to be a part of the team, it will do some modeling, not necessarily A-class, just working in Alias. And this question or this small task may be given to figure out what the guy actually knows. Because you can solve it multiple different ways, of course. But these skew and edge shenanigans, they're not actually, as I said, described in the documentation. Not a lot of people really talking about that, but it actually is it can cause a lot of issues if you don't know this kind of nuances in their behavior. So this is the question which people will may ask you if you ever decided to apply to the position in the design bureau for Alias. All right, guys, that's it. Thank you very much for watching, and I will see you in the next one.